I debated whether to film this or not, but the whole point of my videos is to help people out, learn a few things, and if you can learn from an expensive mistake, then I feel like I definitely should film this. As stated in previous videos, I got my Astrocomms board after 5 months, finally. And so I also ordered some fuse blocks and some distribution buses. I already had my audio amp. This is a 12 24 volt audio amp. One of the speakers that I have a pair of. 3D printed adapter for tool battery, Kobalt tool battery, and a breaker switch. And the converter that takes 12 or 24 volts in and outputs 5 volts. I check my wiring over and over and over. Tool battery. Power goes line in on the circuit breaker. Load out of the circuit breaker goes to this bus bar. Negative from the battery goes to this bus bar. So it means these two together are 24 volts, not fused. Then I took the ground from here into the converter, 24 volts into the converter, 5 volts out to this fuse block, 5 volts also out to this distribution bar, just because these are sold in pairs and I haven't bought another pair just to get the ground one. So just for testing, I use this. These are all connected. I also put a little meter on it. These parts are all from Jason Charlton's videos. So this should be 5 volts because it's coming from this fuse block, this ground coming from the converter. Then I have 24 volts coming off of this, going into this fuse block. I have a meter going also from the positive and to the ground for this. And I have a wire going from the positive to my amp and negative wire from the amp back to this bus bar. So, turn the power on, battery should flow here, 24 volts on this meter, 5 volts on this meter, 5 volts going into the Astrocomms board, 24 volts going into this amp, 2 lines coming out of the Astrocomms. It has left, right, and ground. So I hooked up ground to the negative in on the amp. I hooked the right audio to the positive in on the amp. This is a mono amp. So left and right, when this is all made for real, will both go to the in positive, and then the ground goes to the negative. And then I've got positive and negative 24 volts in, and then for audio out, I have negative and positive going to one speaker. I have 2 of these, but just for testing, I just wired up one. And I'm not sure if the SD card on the Astrocomms comes with the sound files loaded or not. One thing I did notice is you can't get the MP3, the mini SD card out, because it bumps into this capacitor. You actually have to lift this board off of the main board. Okay, not a big deal. All these boards can be removed. So what happened when I flipped the switch? Smoke. I have blown up about $300 worth of electronics today, and it's a stupid mistake. Like I said, I went over my wiring over and over again before I applied power, making sure that my power, my bus bars, my fuse blocks, everything was right. The one thing I didn't double check, this converter. It has inputs for the 12 or 24 volts in and the 5 volts out. I had them swapped. I put 24 volts into this converter where it's supposed to put 5 volts out. So, what did I see? I saw my Astrocomms board pop and smoke. I also saw some smoke coming from this circuit breaker. So, I turned everything off. I eventually found what I did wrong. I unplugged everything, turned the power on, hoping to corrected this issue, hoping to get 5 volts on this meter and 24 over there. This meter was closer to 7 volts. Yeah, I fried this board. This chip here has popped, so this comes off, but that died. This chip here, 328P chip, same chip as on a Arduino, except this is a surface mount version instead of the pin version that's on a standard Arduino board. That chip popped. I have no idea if anything else here, if the 5 volts into this that I was giving, God knows what, 24 volts probably, maybe negative 24, I don't know. I don't know if these survived. I don't know if this survived or this survived. They do individually come off, but not sure. I guess I could take them off and hook them to a computer and see if they at least light up. But I'm calling this whole board dead. This can be replaced fairly easily. I don't think that the code's available that Ben uses on his boards. I might be able to get it from him, so I might be able to try and replacing that fairly easy. This, being a surface mounted chip, is more of an issue. And then, bigger issue than that is what else got fried on this board. And basically, I don't want to deal with it. So, this board I'm considering totally fried. This, because when I hooked it up right, was giving me nearly 7 volts on this meter. I think this is probably fried too. It did make me wonder if the tool battery, fully charged, gives a little bit more than 24 volts, if that makes this give more than 5 volts to this, which would be a terrible thing. But I think that this is probably fried, and even if it's not, I mean, it's got to be fried. Hooking it up backwards, this has got to be fried. So I'm counting that as dead. And I'm counting the circuit breaker, which still flips, but I saw some smoke coming out of this. So I'm counting this as dead too. Also, my room smells like burnt electronics, but when I put this up to my nose, you probably can't see it in there, there's some vents in there. Put my nose up to that and smell. This smells burnt inside. I think I have possibly damaged the battery. I'm going to press that and that light comes on. Okay, that's good, but I don't know if I want to hook this up to my drill and risk ruining my drill, which came with this and a 4 amp hour. And part of why I got it was to use the 2 amp hour in testing just like this in case something like this happens, so I don't screw up the other battery that came with my drill, so I can still use my drill. Side note about this, I've decided not to use a tool battery. I'll talk about that in this video too, I guess. I read on the Michael Badley Facebook page that the Lowes 24-volt Kobalt batteries have the battery management electronics in the battery and not the tool. That's why I was going to go with this. I read on the astromech.net forums that some of the battery electronics are in the tool and some are in the battery. Specifically, the discharge protection is not in the battery on the Kobalt batteries, according to posts on astromech.net. What that means is if my droid is running on this and it runs this down, the protection circuit is in the tool that determines, okay, this thing is discharged to the safe level and it stops the tool from being able to use it anymore, so you have to charge it. If you're not running this in a tool, then that would mean that this hooked up to a droid would just keep drawing power more and more and more, and this would go below the safe level of discharge, which could damage the battery pack and possibly start a fire. So who am I going to believe? Am I going to believe astromech.net? Am I going to believe the Badly Facebook posts? Or am I going to go online and see if I can find technical specs on the battery? I have decided not to use a tool battery. I was thinking of doing 2 6-amp-hour batteries, one just to power the drives and one to power all the electronics, but I have since changed my mind, and I am going to do the same setup that Jason Charlton has, because why reinvent the wheel? I like his setup. His setup seems to be working for him, and so I'm going to be buying 2 12-volt batteries and running his same setup. So, big lesson learned here: when checking your wiring, check everything. This one little mistake of not double checking the bottom of this thing before I powered it on has just cost me this, and I probably will just consider this garbage because it smells funky and I don't want to put it in my tool and possibly destroy my drill if that battery has been compromised in any way. So don't be like me. I'm just so upset at myself that I made that stupid mistake. Have I learned a lesson? Kind of. I mean, I checked my wiring over and over again. I just forgot to check one thing, and that happens. You know, people make mistakes. So I know to check my wiring. I know to check things. I just missed it. I just absolutely missed it when I was hooking it up, that I had this pair of wires and this pair of wires swapped. So maybe it's fate. You know, it took me 5 months to get this board. Ben also commented when he said he would send out a replacement that he would also put the relay board in that protects the motor controllers, because I told him I was going to order that, but I didn't want to order it until this had arrived, and he said he'd throw that in, and I didn't get that. So the whole experience with this Astrocomms, just for me personally, has been not good. And apart from the fact, there's the fact that if this works, it's great, but I'm not sure how much of the code he's releasing. I haven't seen the code anywhere, so if you want to change any of the code and recompile, I don't know if you can do that or not. I also don't know how you pair your PlayStation controllers with his board. I didn't see that anywhere, but regardless, I had just made the videos that I bought all of the other parts to do it the, let's call it the traditional way, with the Arduino Mega 2560, and I already had an MP3 trigger, and I had Markduinos, so it looks like I'll be going that route and getting the same batteries that Jason Charlton uses instead of the tool battery, so I'll basically be copying his whole design. So, lesson learned, I guess. Check your wiring, check it twice, check it 3 times. I did all that. So check all your devices too. I double checked that I had positive and negative going into the 5-volt input on the Astrocomms board. I've verified that I've got the 24-volt plus and minus correctly going into the amp board. I just did not check this giant 5-volt converter board to make sure that I had its wires set up correctly, and it's cost me quite a bit here. So that's the way it goes sometimes. I just, yeah, sucks, but I will recover.